Hello and welcome to another video on DesignScript. In this video, I'm going to be discussing surfaces, in particular B-spline surfaces. So I'll begin by importing the standard geometry library. And creating a series of points. So B-spline surfaces are very similar to B-spline curves. If you haven't seen that video, I would encourage you to look at it because the discussion of how um, in essence, a kind of straight polyline with straight line segments is smoothed into a B-spline surface that's smooth and continuous is essentially the same process that goes on with a B-spline surface, just in 2 dimensions. So it's worth watching that video just to get an idea of the fundamentals if you don't have it. Otherwise, if you have watched it, um, you'll notice these similarities, and essentially everything you've learned there just can be taken over in 2 dimensions. So we'll begin by creating a series of points, um, uh, and this is because these require a 2-dimensional array of points. Things like replication guides are incredibly useful. So I'm going to use replication guides to create a 2-dimensional grid of points. If you're not familiar with that syntax, feel free to watch that video. So if we see this line right here, we see we now have a square grid of points. Okay, so I can make a surface now by simply saying B-spline surface, similar to the B-spline curve. We can say by points, and add in our points there, and it'll create a surface. Okay, so by points is similar to the by points in B-spline curve. We can also similarly do by control vertices in B-spline surface um, to generate a smoother version of the surface. But I'll just begin kind of deforming some of these to give you a better sense of what's happening. So why don't we can deform, say, one of these points. So we can say P44 is equal to P44.translate. I'm going to translate it up a bit. Maybe move it up 2, and maybe I'll choose another point. Translate. All right. So I rerun this, and um, so we can immediately see what's going on. So in other words, this surface is going to hit, or it's going to intersect every single one of the points specified, and it'll make the smoothest possible surface based on that. So we can actually change the degree similarly to we can change how we change the degree of curves by specifying 2 extra parameters. So we can say like 4 and 4, and this is going to be a 4th-dimensional surface in the u and v direction. Before it was a 3-dimensional, a 3rd degree, or even make it a 6 and 6. And now we can see it's getting very, very wavy, and there's even some kind of odd movements that weren't expected going in there. So as you'll notice, this might not be what's desired. Perhaps you simply wanted a kind of 6 degree that's much more smooth than a spiky pattern. We can similarly do by control vertices, oops, which operates just like the by control vertices and B-spline curve, and that sort of does it essentially treats these input points, like I said, as control vertices. So like in a curve, um, normally you can think of this as a kind of almost like a polyline, but in 2 dimensions. And this one's being progressively smoothed and smoothed and smoothed and smoothed 6 times before. So here, if I kind of do a secondary curve, again, this line, say from one point to the next, is going to be intersect on the tangent of this surface. This is an incredibly kind of high like higher level discussion of what would otherwise be kind of like somewhat complex math. But suffice it to say, this one function by points and by control vertices allows you to construct B-spline surface patches, and hopefully gave you a brief introduction into some of the math behind it. All right, thank you for watching.